So I liked this comment because it alludes to a very important truth. It's got also a false statement in here that if you breathe something in, it's going to stay in your lungs forever. What can happen when you're talking about radioactive materials that are aerosolized is that if they're small enough, they can actually pass through the barrier in the lung alveoli and make it into your bloodstream. And when that happens, that's probably if that radioactivity is an alpha emitter, meaning that it gives off a helium nucleus when it undergoes radioactive decay. Because that helium nucleus, it has what's called a very high linear energy transfer, which means it gives a very large dose over a very short period of time. That track, as that alpha particle is punching through the cells, it's causing a lot of damage, unlike, for example, a gamma ray, which might only interact with one electron as that photon passes through your body. And that one electron will then ascribe dose, but it's only that one electron instead of all the electrons that are being ripped from the atoms as an alpha particle is traveling through material, like living tissue. And so an alpha particle on your skin, it's not going to do anything other than give dose to the dead layer of your skin, which you don't care about because it's not really going to, it doesn't have a biological effect. But inside of the body, then it does have a biological effect, and it's quite sensitive. So when it comes to a nuclear accident, that is probably the most sensitive intake route. If you're not eating it, the next is going to be breathing it. And if it's already in the air, then that means that there's a potential for any of it to be respirable, so that it's not filtered out with the cilia in your bronchial system or even your nose hairs. And so there's a good point there, but it doesn't mean that it's going to stay in your lungs forever. I mean, you can get, say, a wire or something, and if you breathe it in, that might stay in your lungs forever. So if it's large enough, that's possible. But the ones that we're really concerned with in radiation safety are not this thing that this individual is talking about, but ones that can be lofted and travel. And if they're lofted and traveling, that means you're going to have a certain fraction, something in the range of about 3 microns in diameter, give or take about an order of magnitude, is what can get down into the lung alveoli and give dose to a person, because some of that is going to pass through the blood barrier and get into your circulatory system and get deposited in your organs and give you dose. So I hope that helps. The actual discipline there is called health physics. It's radiation safety, radiological protection. That's actually the kind of teaching and research that I do here at NC State. Like with my dosimetry system here allows me to basically turn anything into a dosimeter. Well, insulators anyway, translucent insulators with thermoluminescence and optically stimulated luminescence. And so I'm in my lab doing videos at the moment. So kind of cool.